Alright, today we're going to talk about theoretical and experimental probability. Really quick, if you look at the word theoretical, TH starts with the same thing as think. So theoretical and think both start with the TH. So theoretical is what should happen. We'll underline the word should in an experiment. You determine theoretical probability by using math, we'll say. I'll explain that more in just 1 second. Experimental probability is what has actually happened in an experiment. So it's determined by the outcome of an actual experiment. A lot of times you can look for keywords like what should happen, or if it says someone spins a spinner or rolls a die. Spinning a spinner and rolling a die indicates experimental because you're actually doing the experiment. Alright, so we have the formula. So favorable outcomes, we'll say what you want. Over the total. That's going to be your first step, is to always find the total that you have. Experimental is what happens over the total. So an example with theoretical, so the probability of selecting a yellow jelly bean if the bag contains 150 jelly beans and 25 of them are yellow. So your total is 150. What we want is the 25 yellow. Simplify. We'll make a note just so we remember to do that. So the greatest common factor would be 25. When you divide 25 by 25, you get 1. And 25 by 150, you would get 6. Experimental. Gina selected. So she's actually doing the experiment. Cards out of a deck at random for 30 seconds without replacing them. Out of the cards drawn, 18 were black and 12 were red. So 18 plus 12 gives you the total, which is 30. Okay, so what is the experimental probability of drawing a black card? Okay, so 18 out of 30. Your greatest common factor would be 6. 18 divided by 6 is 3. 30 divided by 6 is 5. Now they may ask you to convert these to decimals or percents. You might see that on a test coming up. That's a hint for you. So 3/5 as a decimal would be, we'll multiply by 2, get 0.6, which would be 60%. This is important too, so we'll start this just so you remember it. Another hint for you. So as the number of trials increase in an experiment, the experimental gets closer to the theoretical. Alright, so we'll start A, B, and C by determining if it's theoretical or experimental. A says Jimmy is rolling a dice in a game. So he's actually doing the experiment. So that's experimental. Alice calculates, therefore that's thinking, the probability of winning the school raffle. Theoretical. Mark and Jose determine the likelihood of rolling double twos on a set of dice. So again, we'll see theoretical. Okay, let's try numbers 1 through 6. So we're given a number cube that has 6 sides. The probability of rolling a 1 would be 1 out of 6. An even number would be 2, 4, and 6, so 3 out of 6, which reduces to 1/2. And again, it's good to know the different conversions with FDP. 3 or 4 would be 2 out of 6, which simplifies to 1/3. The probability of 7 would be 0 out of 6, which simplifies to 0. A number greater than 2, that would be 3, 4, 5, and 6, so 4 out of 6, which simplifies to 2/3, not 5 or 6. If we marked out 5 and 6 from this list, we have 4 numbers left. So again, 2/3. So a survey was taken at a local middle school, and the results are represented in the table below. First, let's get the total number of students that we have. So we'll add together 275, 150, and 75. Okay, so 7 plus 5 is 12, plus 7 more would be 19, plus 1 is 20. Then that gives us 500, so a total of 500 students. Okay, so probability of a student preferring to read a magazine, that's 150 out of 500. GCF would be 50, so that's 3, and then if you divide 550, gives you 10, so 3/10, which is 30%. Listens to music, that's 275 out of 500. Divide that by 25, it's 11 out of 20, which if they asked you for that as a decimal or percent, we could multiply by 5 to make that 100. 11 times 5 is 55, so 55%. You could always do long division. The top number, 11, goes inside the house. Let's start number 9, another hint for you. Okay, so let's set up a proportion. Suppose 1,000 students attend anywhere middle school. How many would prefer to read a book? So we'll put X over 1,000. So we'll go back to this middle school up here. So 75 out of 500 preferred reading a book there. Okay, so we'll cross multiply, get 100x equals 75 times 1,000, which is 75,000. Divide that by 100, and we'll get x is equal to 750. Okay, this next page gets into some sample questions you might see on the SOL. We'll go through a few of these, and I'll let you try some too. Number 1, the faces of a fair 6-sided number cube are numbered 1 through 6. Based on the theoretical probability, so theoretical again is what should happen, if a number cube is rolled 60 times, how many times should a 2 be rolled? Okay, so if we think about it, we have a 1 out of 6 chance of landing on a 2. So if we roll it 60 times, 6 times 10, and you could set it up with proportions, or 60 equals 6x, get x equals 10. Number 2, the faces of a fair 6-sided number cube are numbered 1 through 6. A number cube is rolled 25 times and it lands on a 4 5 times. That's experimental. We're actually doing the experiment. So it lands on 4 5 times. So that would be 5 out of 25, which we'll divide that by 5 and get 1 5th. We'll label that. Let's put an EXP over here for experimental. Okay, so theoretical. Let's put TH. That would just be 1 out of 6. So the difference there, so we know that the bottom's the number of times that we rolled. So the difference would be 1 roll. Because 6 minus 5 gives you 1. Look at number 3. Let's star this one. So Craig has a 6-sided number cube and he rolls the number cube 250 times and records the data in the table. So total is 250. So based on the data shown, the probability of rolling which number has a larger theoretical than experimental. So we know that theoretical would just be 1 out of 6, which that would reduce to, or we'll change it to a decimal, I should say, get 0.16 repeating. Okay, so now let's try these experimental probabilities. Alright, so landing on a 1 would be 37, that's coming from right here, out of 250. Which if we change that to a decimal, that gives me 0.148. We're looking for the larger theoretical than experimental, so 1 would work. If we try 2, that's 52 out of 250, which that would be 0.21 if we rounded. That is bigger than 0.16. We'll mark through 2. So because 52 doesn't work, obviously 62 wouldn't work. If you did divide that, you would get 62 divided by 250, which is 0.25. If 37 worked, obviously 16 would work. If you check that though, 16 divided by 250 is 0.064. We'll write that one down. Okay, 5 is 44 divided by 250, which is 0.176, doesn't work. And then 6 is 39 out of 250, which is 0.156, so that one works. So now you're going to complete numbers 4 and 5. And on the next page, page 71, let's look at number 6 really quick. I've seen this question on previous SOL practice questions and on JLab. So we're looking for which experimental, or which bill has an experimental probability of 7 out of 25. So Peter picks one bill at a time from a bag and replaces it. He repeats the process 100 times, so the total is 100, and records the data in the table. So $1 is 28 out of 100. If you divide that by, we'll do 4, you get 7 out of 25. So that would be the answer right there.